Welcome to Operations Research Sensitivity Analysis Lecture Series by Professor Joyjeet Ghose. This is the second lecture of a 4-series lectures. This lecture will be on Introduction to Sensitivity Analysis, Need of Sensitivity Analysis. He will also be discussing the sensitivity analysis of change in the objective coefficient of non-basic variable by Revised Simplex method. So, do not miss and watch the full video. For the next video in the lecture series, please click the suggested video link above. You may also click on the playlist at end of the video to access all the videos. Please subscribe this channel and yes, do not forget to like and share. Also click on the bell icon to receive instant information of new videos uploaded. Thank you.
Hello friends, welcome to this lecture. In this lecture we will be discussing the sensitivity analysis of change in objective coefficient of a non-basic variables, which basically means if there is a change in the coefficient of a non-basic variable in the objective function, how it will affect the final solution. So in the last lecture we have discussed the importance of sensitivity analysis. I am not going to discuss the sensitivity of the importance of sensitivity analysis in this lecture. Rather, I'll directly move on with the solution using revised simplex method. So in this lecture we'll be using revised simplex method to solve this linear programming problem, and then we'll carry out the sensitivity analysis to see the effect of the change in the objective coefficient of a non-basic variable. So if you are not interested in revised simplex method, you can skip this lecture. So if you are interested in revised simplex method, this is your lecture to understand the sensitivity analysis from reverse simplex point of view. So this is the problem that we had solved in the last class using conventional simplex method. So in order to carry out the sensitivity analysis, you have to solve this by revised simplex method. So if you are watching this video, it is expected of you that you should be able to solve this by revised simplex method, and at this point you pause the video and solve this problem by revised simplex method, and then I'll show you the results of this revised simplex method, and I'll show you how to carry out sensitivity analysis to check the effect of the change in the objective coefficient of a non-basic variables. So pause this video at this point of time and solve the problem by revised simplex method. In the second, it's going to start with solution x3 is equal to 3 and x5 is equal to 9, and then we find that it is not an optimum solution because c1 minus z1 come out to be positive. So c1 or x1 will be entering variable. To find out the exiting variable, we check this theta, and theta comes out to be 2755. So my x5 will be the exiting variable. So x1 will replace x5. So next will be x3, x1. So this will be 655, 27 by 5. And you can check this is the optimal solution, and the solution is 138 by 5. x3 is equal to this, and x1 is equal to this, x2 is equal to 0, and z is equal to this. This is the optimal solution. Now, thing is that if what are the non-basic variables? So x2 is a non-basic variable, x4 is a non-basic variable, x5 is a non-basic variable. Now if c2 is changed, c2 in this case is 3. If this is changed, let's say change it to c2, how it will affect my solution? So this solution will be like this. So it will be c2 minus 33 by 5. Once it is less than 0, then c2 must be less than 33 by 5. So this is the sensitivity of the solution. So, and if c2 is less than 33 by 5, then the solution will remain optimum. If 3 it is changed to 4, then also solution will be optimum. It is changed to 6, then also the solution will be optimum. But if it is changed to 7, the solution will no longer be optimum. It will be 2 by 7. So this is an this will be an entering variable. This will be an entering variable. So x2 will be entering. To find out which will be the exiting variable, we have to find out P2 bar. So let's check. So here, this is the my solution. So here in the third iteration, so if C2 is 7, then what happens? We will start with the third iteration. We are not bothered with the first iteration and second iteration. We will keep on iterating from the third iteration. So here I put 7, so it becomes 2 by 5. So this is an entering variable. So x2 will be entering variable, entering the basis, and what will be entering the exiting the basis? We have to find out C2, P2, and from that we have to find out the theta. So P2 will be this. We know the B inverse, and accordingly we will find out P2. P2 comes out to be 1 by 5 and 7 by 5. My initial solution was x3 is equal to 6 by 5 and x1 is equal to this 27 by 5. Okay, so from this we find it out. 2 will not be here, I think. Yes, 2 will not be here. Please ignore this 2. From this we can find out theta is equal to 27 by 7. So that means x1 is the exiting. X1 exits. X1 exits the basis. So here x3 and x1 is replaced by x2. It come out to be 3 by 7 and 27 by 7. And we check for optimality. We check this is negative, this is negative, this is negative. So therefore this is optimal solution, and this is my z. So this is optimal. Okay. So in this manner we can use revised simplex and sensitivity analysis, particularly for finding the sensitivity of a solution if there is a change in the objective coefficient of a non-basic variables. In the next lecture, we will see by conventional methods the sensitivity of a change in the objective coefficient of a basic variables. Third lecture will be on by conventional method, and the fourth lecture will be by revised simplex method. So I hope you understood. If any doubt, please feel free to contact me. I will try to clear the doubt. And thank you for watching this video.